Welcome to Computer Science with Mr. Walks. Let's take a look at what we're going to look at today here in computer science. So let's start by learning out who Mr. Walks is, a little bit about myself. So I was born on August 23rd of 1969 here in Winnipeg, right down the road at the Grace Hospital. From there I went to high school here in Winnipeg and then went on to the University of Manitoba and the University of Winnipeg, and currently also attending the Memorial University in Newfoundland with degrees in arts with a history major and a philosophy sociology minor, a computer science major and a math minor, and a degree in education. As well as those programs, I also studied and got certificates in web design, creative writing, journalism. I've done IB training in computer science and theory of knowledge, and I'm currently working on my Master's of Education with a specific focus on computer science. Before I started teaching in the late 90s, I worked as a freelance artist. I worked with special needs children, and I also worked in the computer science industry as a programmer. So what have I taught or continue to teach to this day? So I teach computer science 20S at the grade 10 level, 30S at the grade 11 level, and 40S at the grade 12 level. I also teach the IB computer science both at the grade 11 and grade 12, both at the standard level IB and the higher level IB. I've taught all the IB theory of knowledge, both the grade 11 and the grade 12. For those who don't know, theory of knowledge is a philosophy course. In addition to that, I've also taught math, including grade 9, 10, 11, the RTI and math numeracy courses of which I developed. I've taught information technology, sometimes called digital technology, both at grade 9 all the way up to grade 12 level. I've taught social studies, grade 9, and a peace and conflict course, which I created myself. I've taught photography at the 9-10 level, visual arts, and alternative education. In other words, a lot of stuff, from both core courses to option courses, vocational to IB, from the sciences to the humanities. That's where my teaching career has taken me. On a personal level, I'm a teacher. I do have a wife, 2 children, a cat, a dog, live in St. James myself. But what you want to know is about the course in computer science. So let's take a look at what is computer science. So an astronomer named Clifford Stoll once said, the first time you do something, it's science. The second time you do something, it's engineering. And then by the third time, you're just being a technician maintaining it. So the word science is often thought of as a purely academic study, and the word engineering as a very practical career-based study. I'm going to attempt to argue that computer science is a little bit of both of those. So we live in an age now that has access to more information than at any other time in human history. But is that really better? For example, have you even looked at all the photos you have, for example, on your phone? Have you even looked through all the photos you've just taken this summer? So a lot of this information that we have is just considered to be garbage. When we sort through this garbage and make something meaningful out of it, that is when something becomes useful or purposeful. And technology is something that can help turn garbage into something useful. It was artist M.C. Escher who said, "We adore chaos, but we love to produce order from that chaos." So I'm going to argue that one of the tasks computer science does is take the information chaos out there of all that information and turn it into something of order. All right, let's take another angle at this. You kids are a generation that loves to consume current technology, okay? And people have been serving you technology, but sometimes it doesn't meet your needs. There can often be a disconnect from what tech companies are serving you and what you as a consumer want. One example that I can use with my archive of old man knowledge is something called New Coke. If you don't know what it is, ask your parents about it. It was in 1985, the Coke company decided to create a new formula for Coca-Cola. They thought maybe they could compete against Pepsi in sort of taste tests. They made it a little sweeter. But once they put it out there, there was a huge backlash against it. The company realized that nobody liked the new Coke, and they were forced to turn around and go back to the original formula. This is an example of where they want to serve you something, but it's not actually what you want to consume. And I would argue that technology has stereotypically kind of been that way, that what they serve you up in technology only meets a certain demographic of people and not necessarily what you want. Nobody in this room can doubt that technology has had a huge impact in the modern world and continues to this day. I mean, sometimes I ask the question, how many computers have you just used today? In your car, on your phone, on your tablet, in your hand, all the technology in some ways has a computer built into it. From checking an app to go to get when the bus is arriving, to changing the temperature of the room, to playing a game, you today are the mass consumers of new technology. So, you can stay a consumer, which puts you on the outside. Or you can be part of the inside. You can be part of the serving of that technology. Isn't it more fun to be someone who serves rather than just consume? So to me, that is another argument for computer science, is that it provides you the opportunity to be someone more on the inside of this technology. Okay, you can be a technology insider. All right, so let's break the terms up again. Computer and science. So when I say the word computer as an older person, you guys might think that I'm drawing up images in my mind of things like this, that's what computer means to me. And you might be right. But to your generation, it may have a completely different connection to other types of words and concepts. To me, the word computer is too big to even apply to one thing. A computer is a category of things. So, right now, computers are integrated into literally everything that you do now. But let's go back to the beginning. The word computer, from the 1600s, from the Latin com, to come together, and putere, to settle an account, was really a mathematical term about settling up accounts. And the first time the word computers was applied, it actually meant people. People who did calculations were the computers. So the original computers were people. It was around 1946 that the word actually started applying to devices rather than people. In the picture you see here, you can actually see a room called the computer room, which was these women that would do a lot of calculations in their job. So the word itself is not really that old in terms of language itself, but it has a huge impact on our modern world. All right, let's put it this way. Imagine you're in a room with one light bulb and one light switch that were connected. And when you flick the switch on, the light went on. I think that's a pretty easy concept to imagine. Now imagine there's one switch that switched on other switches that switched on other light bulbs. Okay, again, maybe not that, little more tricky, but not necessarily that hard to imagine. So that you flick one switch, it flicks a series of switches to flick on a series of lights. Now imagine an entire room set up this way, where one whole wall was light bulbs. The other wall was all light switches, one switch for each bulb, and then a third wall had less light switches on, but that you could flick one switch and it would flick a series of switches to turn on a series of light bulbs. Well, if this sounds fairly simple to conceptually grasp, what you're seeing is essentially what a computer is. Hitting a master switch is kind of like typing on a keyboard, which triggers the correct switches internally to light up the correct bulbs, which would be your computer monitor, to make words like hello world appear within that monitor. It's creating the logic behind how those master switches work, which is what we do when we step in to work in the field of computer science. So, all right, so let's get back to the word science. This is a word you've heard all the way back since the beginning of your school setting. The word actually has Latin origins. It essentially meant originally what is known, or in other words, it was synonymous with the word knowledge. So originally the word science and the word knowledge were often interchanged. So why don't we say that if we put computer and science together, computers, the people who do calculations, and science, knowledge, it's people who do calculations and have knowledge, or who know things. This could be a way to describe what computer science is. But let's keep rolling with that. What is the actual words together mean? So when a lot of students come into this class, this is their expectation. Take computer science, something happens, and you get to make video games. This is not untrue, but we need to explore what that question mark really means. Like, what do these terms mean? How do we learn computer science? What makes that question mark happen so that we can get to our end point? And again, it may not be making video games, but knowing the teenage mindset, it a lot of times is. All right. So at its highest level, computer science is both a theoretical subject and a practical subject. It's an abstract theoretical in that it's an academic study that you can do all the way into a high-end university degree, both at a master's or a doctorate or a bachelor's level. But as well, computer science is a job. It's a practical, concrete, vocational job you can get into. Programming and jobs within computer science, might be argued, are some of the hottest jobs in our modern economic fields. All right, but let's get into some more definitions. Once again, computer. A computer now is a very big word. It's a device that is a tool that we use to help with calculations, whether that's a tablet or a calculator or a Mac or a PC or a watch or a video game console. It is the tool that's majorly used within this field. In a way, it's like a microscope is used in biology or something in a similar science field. Now, what about science? Well, as I said, science is knowledge, but it's also really a method. We've heard of the scientific method before. It's a traditional way that means step by step working its way through something. So if we put those things together, the tool used and the method incorporated, computer science generally means coding or programming. This is how the tool and the method come together to accomplish the goal of solving problems, which to me is the major goal of a computer scientist, solving problems. So let's try rewriting this name. Instead of computer science, what if we called it methodological, which means science, math, typed, coded, it's all kind of put together following a method. Digital. Take away from the word computing, open it up even a little bit more, just say digital, electronics, so to speak. Problem solving. Methodological digital problem solving is a little bit of a mouthful. So I think the easiest way to describe computer science is step-by-step problem solving on a computer using code. Okay, by the way, that's not all computer science is, but that is the majority of what we'll be doing within this course. Okay, so how are we going to do this? How are we going to study computer science? Well, you're going to figure out what a problem is. A lot of the course I'll be doing that for you. I'll be presenting a problem to you in the form of an assignment. But in things like perhaps your final project, you will be building your own problem, like making a specific game. Then you're going to decompose or break down the problem using logic. This is something I'm going to help teach you how to do, is how to take a problem and break it into components or decomposed. For example, if we were making a Pac-Man game, how do I get the ghost to work? How do I make walls work, etc.? Okay, once it's decomposed, then I have to solve that problem using some kind of a method. And again, this is part of the learning process. I'm going to teach you how to write code, how to build through the problem, how to devise a method, how to test that method, which happens to be the next step. How do we test it? Well, again, in computer science, this is a little different than other sciences. You essentially run it. Did it work? If not, revise it. Go back and figure out how to fix it. This is how software is in fact developed. This is called sometimes the software life cycle, where you figure out what the problem is all the way up to testing it and then possibly revising it and making it better and better and better. All right. As a student, you might be sitting there thinking, this important question, and it is an important question, is computer science hard? Someone once said computer science is really hard. Well, let's start with a story. Pablo Picasso was out for lunch with a friend one day when he just drew something on a lunch plate, and he drew it all in one stroke of his pen. Can anyone in here figure out what he drew if I show you this picture? So I'm going to guess a lot of you figured it out right away, that it's a dog. But could you even be more specific? What kind of dog? This picture of a dog was later sold for $90,000. And when Picasso was asked, how long did it take you to learn to draw like that? His answer was, all my life. Now, although this picture looks simple, if I asked you to draw this all in one stroke, not using this as a model, but just off the top of your head, it wouldn't be as easy as you'd think. And then if I said to you, okay, if you were able to do that, now draw a camel, okay? And when Picasso was asked to do this, he did, okay? We all have a natural tendency to say to ourselves, that looks simple, I can do that. Sometimes this is described philosophically as elegant simplicity. And technology is this way. We all tend to think, oh, it looks so simple. But behind that technology, what makes it seem simple is a lot of complexity and a lot of practice to get that elegant simplicity that we all experience. So, is computer science hard? Yes, that's the right answer. It is hard, but let me stop there before all of you drop the course. If you think about it, isn't everything worth doing hard? Think about it. Just because something's hard doesn't mean that's something you shouldn't do. Let's take, for example, learning another language, or playing music, or being good at sports, or riding a bike, or learning to swim. The list goes on and on. All the things that are worth it were initially hard to do. So if you're looking for a course that's easy, I can't provide that for you. But if you're looking for something that's worth it in learning how to become that way, then that is the answer. Yes, it's hard, and yes, it's worth it. So how do we learn to think as a computer scientist? What do we need to do this? Well, to think as a computer scientist involves a traditional science type thinking as well, but I would classify this more as computational thinking. Learning to think with computations in mind. Sometimes this is also called algorithmic thinking or programmatic thinking. It trains the mind to think more like a machine in the way it solves problems than in the way like humans solve problems. But it's very similar to a traditional scientific method. Let's break it up into 4 steps or 4 areas. 1, we've already mentioned this, decomposing a problem, breaking it up into components. This is understanding a problem in a deeper way. Okay? 2nd will be designing an algorithm or algorithm design, finding a way to give instructions to properly communicate how that solution goes. In computer science, this is generally done through some form of coding. Okay? How do I remember information, the data? How do I formulate the steps, the algorithm itself? Okay? Now, that's the basics of computational thinking. Decomposing the problem, building up an algorithm. All right, so as computer science gets a little more complicated, well, now we can take computational thinking and expand on it. So it can also involve things like pattern recognition, looking at results, seeing if algorithms can be improved and the design can be sort of replicated in better fashions. We can look at things like abstraction, taking the real world and modeling it within the solution. So this is a little more of the higher end of computational thinking. And you're going to see these things reflected in the units and the modules as you progress through various computer science courses that you could take. So how's this course going to go? Well, here in computer science, I'm going to move towards learning the study of computer science and teach concepts that apply, which can formulate things like a body of knowledge, a collection of computer science facts, as well as a method, a process of solving computer science problems, as well as some specific tools that you're going to learn. So the body of knowledge follows a general order that you could call units or modules that will encompass a course or across multiple courses, depending on your pace and which courses you decide to pursue. This can lead to further specialization within computer science. And the order is sequential, and each unit builds on the previous unit and leads towards the next unit. Although there are certainly exceptions to this, computer science is generally a gradual step-by-step. In other words, you can't jump into the middle. Each unit builds off the unit before that, in general. Okay? The method in computer science involves a variety of techniques within problem solving and programmatic thinking. So in general, the course will involve me giving a presentation or an example and a discussion that will show a concept in action, and then a series of problems that you will be working on, which I will assess you on, and then conclude with some kind of final assessment, whether it's a test or a quiz or something, that will check for mastery of that content. The tools that you'll be using as a computer scientist involve writing code, which means typing on some kind of device, using and adapting software for that purpose. This is called what's known as an IDE, and we'll learn more about that later. And learning how to present and share your solutions with me. So there's no doubt that the tool of a computer scientist involves writing code, which involves typing on some sort of device. So this would involve generally a laptop or a desktop computer. In practicality, you'll be using one of the computers in the room or your own laptop all throughout my computer science courses. Now, all three of these will be improved and will evolve as you study further computer science and connect three main areas. The tools, right? So at the grade 10 level, it's just programming language. At the grade 11 level, learning to use the IDEs more powerfully. And at the grade 12 level, using something called code repositories. The programming practices or the methods level. So at the grade 10 level, it's more like programmatic thinking and basic problem solving. At the grade 11 level, I introduce something called unit testing. And at the grade 12 level, you can even get into things like design paradigms and design techniques. In terms of content, I'm not going to read the entire list to you, but at the grade 10, 11, and 12 level, each level of content just continues to build off the next one and move forward throughout the courses. The general learning outcomes of a computer science course include the following. 1, problem solving and design. How does the actual problem get solved? What is your innovation in solving it? How does the user interact and experience the solution? And how does that solution respond to user errors? This is about 40% of what I assess on, is did you actually solve the problem? Next section would be the knowledge and the understanding. So again, this is the factual-based stuff. How is the solution divided up logically? How is the information stored? What are the tools that you used in processing it? This is about 30% of my assessment. Then we have language, style, and standards. Because computer science is essentially a written discipline, although it's typed, the style in which you write that so that it can be communicated to others is a portion of what I'm assessing you on, about 20%. And then finally, communication and collaboration. If you're going to create a solution, you're going to need to communicate that to me. So that's a big part of your mark, is how well did you present your solution to me. This is all bigger part of the general learning of this. It's a general learning outcome. But you'll see in the practical sense when we get into the course, this is how it all fits together to put methods and knowledge together in computer science. So, in computer science, it involves people who do calculations and know things. It is both theoretical, academic, and practical or vocational. It turns information chaos into order. It is step-by-step problem solving on a computer using code. It is elegant simplicity. It allows you to be a server of technology, not just a consumer of it, and it's hard. But then again, what isn't? And maybe finally, as a bit of an inspiration, it's the thing that's used to make video games. So let's do this. Let's get into learning computer science with Mr. Walks.